Ever gaze up at the night sky and wonder, where do all those twinkling stars come from? It's a question that has piqued the curiosity of humankind for centuries. As we look up at the vast expanse of the cosmos, we can't help but marvel at the beauty of the stars, those tiny pinpricks of light strewn across the inky black canvas of the universe. But stars are more than just beautiful spectacles. They are cosmic powerhouses, the lifeblood of the universe. They illuminate the darkness, create the essential elements that form planets and life, and even influence the very structure of galaxies. The universe as we know it would not exist without them. So, how did these celestial bodies come to be? How is it that a simple cloud of dust and gas can transform into a shimmering star? The answers to these questions are as fascinating as the stars themselves. Dive with me into this cosmic journey to understand how these celestial bodies form. Stars begin their life in a rather humble place inside vast clouds of dust and gas. Imagine for a moment a vast cold molecular cloud, a seemingly infinite expanse of dust and gas. It's here in these unassuming cosmic nurseries that the first stirrings of a star's life begin. The scene is tranquil, serene, but a profound transformation is about to take place. Gravity, the great sculptor of the cosmos, begins to weave its magic. Slowly, almost imperceptibly, the molecular cloud begins to collapse under its own weight. The particles within the cloud, once free and independent, start to huddle together. Over thousands of years, these gatherings grow denser and more compact, the gravitational forces pulling them ever closer. Right at the heart of this collapse, at the very center of the cloud, something remarkable happens. A protostar is born. This protostar isn't a star yet, not in the way we understand it. But it's the seed from which a star will grow, a cosmic embryo in its earliest stages of development. As the protostar continues to pull in more material from the surrounding cloud, it grows hotter and denser. Pressure builds, creating an environment ripe for a process that will define the character of our budding star: nuclear fusion. Nuclear fusion is the process that lights up the universe. It's the heart of a star, the engine that powers its radiant glow. At the core of the protostar, temperatures and pressures become so intense that hydrogen atoms begin to fuse together, creating helium. This fusion process releases an enormous amount of energy in the form of light and heat. The protostar continues to grow and heat up until the pressures and temperatures within its core are high enough to sustain nuclear fusion on a large scale. And then, just like that, the protostar sheds its cocoon of gas and dust, stepping into the cosmic stage as a fully fledged star. And voila! This marks the birth of a star. But the story doesn't end there. Our newborn star now embarks on a long journey. This journey is largely spent in what we call the main sequence stage. During this phase, the star is bustling with activity, constantly converting hydrogen into helium through a process known as nuclear fusion. This is the heart of a star's life, its very lifeblood, where it shines the brightest and emits the most energy. Now you might be wondering, do all stars look and behave the same way? Well, not exactly. You see, the size, color, and lifespan of a star are greatly influenced by its mass. More massive stars burn hotter and brighter, yet their lifetimes are significantly shorter. They live fast and die young. On the other hand, less massive stars, they tend to burn more slowly, living longer, often for billions of years. Every star we see in the night sky is living out this cosmic tale. Remarkably, these shining specks in our night sky are the architects of the cosmos. These celestial bodies, through their life and death, shape the fabric of the universe. Stars in their fiery hearts forge the heavier elements. Hydrogen and helium, under intense heat and pressure, transmute into heavier elements like carbon, oxygen, and iron. These are the building blocks of the universe, the very stuff that makes up our world and us. But how do these elements find their way into the cosmos? The answer lies in the spectacular death of a star, a supernova. When a star explodes, it scatters these elements far and wide, sowing the seeds for new stellar bodies, planets, and potentially, life itself. This cycle of star birth, life, and explosive death is the cosmic dance that shapes the universe. So the next time you look up at the stars, remember, you're witnessing a timeless cosmic ballet that has been unfolding for billions of years.